What I've decided to do is go through this quadratics homework and actually do every single one of them. So instead of doing one video, I think we'll do one mini video for each of these quadratics problems. So we'll start with the first one. For each problem, we're supposed to answer the following, and we're supposed to do our work on a separate sheet of paper. Part A, does the parabola open upward or downward? Part B is to find the vertex. Part C, find the discriminant. D, from the discriminant, tell how many zeros each equation has. E, say whether the zeros are rational or irrational. And F, find the zeros by using the quadratic formula. The first problem we're supposed to do is y equals x minus 4 times x plus 5. Now, here are the solutions that I came up with for all of these problems. And we're mainly concerned in this video with the first one. So let's start with y equals x minus 4 times x plus 5. And part A says determine if it opens upward or downward. So for part A, and actually even before we begin, what we want to do is put this in standard form. It's not in standard form right now because it's factored. We could do a lot of stuff with this being factored, and actually solving this is easier if we have it in factored form to start with. But because of the instructions, we're going to just put it in standard form. So I FOIL this out, or I expand it, or I multiply. X times x is x squared. X times 5 is 5x. Negative 4 times x is negative 4x. Negative 4 times 5 is negative 20. So I end up getting y is equal to x squared plus x minus 20. And that equation, I'm just looking to see if it opens upward or downward. So what I look at is I look at the leading coefficient. First, I need this in standard form. I just put it in standard form, so this is ready to go. And I need to look at the coefficient, the leading coefficient. The leading coefficient is 1. That means that this parabola is going to open upward. So part A for number 1, we should have our parabola opening upward. So part A, upward. Now for part B, part B says to find the vertex. So to find the vertex of this, the x-coordinate of the vertex is always found where x is equal to negative b over 2a. So again, I have to put this in standard form. We've already put it in standard form. A lot of this relies on standard form, so that's the very first thing that you should do for all of these problems. X squared plus x minus 20. A equals 1, b equals 1, and c equals negative 20. Now, I'm just concerned with A and B. I don't really care about C when I'm finding the vertex. C controls the up and down shift, so shifting it up and down is not going to determine where the vertex is located along the x-axis. So what I do is I set up my equation. X is equal to negative b over 2a. X is equal to negative 1 over 2 times 1. Now when I do that, I get x is equal to negative 1/2. So that's part of my solution, but it's not the entire thing. This is what I'm looking for in order to find the x-coordinate of the vertex, but I also need to know where the y-coordinate is. So if I go back up here and I look at y is equal to x squared plus x minus 20, if I want to find the y-coordinate, just like with an XY table or a t-chart, I plug in my x value, negative 1/2. I'm going to square that. Remember these parentheses, otherwise I'm just squaring the 1/2 instead of the negative 1/2, plus negative 1/2 minus 20. So y is going to be equal to negative times a negative is a positive. So whatever this is going to be, it's going to be positive. 1/2 squared is 1/2 times 1/2, or 1/4, so positive 1/4. And plus a negative, that's minus 1/2 minus 20. And then I get y is equal to negative 1/4 minus 20. All I did was I took 1/4, subtracted 1/2, and I get negative 1/4. And this will give me y is equal to negative 20 and 1/4. If I write that as an improper fraction, I get the y is equal to negative 81 over 4. So my final answer is, and this again is for part B, my final answer is negative 1/2, comma, negative 81 over 4. These are the coordinates of the vertex. These are not two separate solutions. This is one coordinate. One point, one pair of coordinates. Part C is asking us to find the discriminant. The discriminant is, and let me write this as an equation, D for discriminant equals b squared minus 4ac. So D is equal to, and if I go back up here, first thing I would need to do is put in standard form. I've already done that, and then figure out what A, B, and C are. A is 1, B is 1, and C is negative 20. So B is 1, A is 1, and C is negative 20. And if I use the order of operations, I get that D is equal to 81. This negative times a negative will make a positive, so 1 plus 80 will give me 81. So this is what I'm looking for part C. Part D, I'm supposed to find how many zeros this equation is going to have. So if I go back up to this equation right here, how many zeros does it have? All I need to do is look at the discriminant. I take the discriminant and figure out, is it larger or smaller than 1? This is in fact larger than 1 because it's 81. 81 is larger, is it larger than 0? The discriminant is larger than 0 because 81 is larger than 0. And since 81 is larger than 0, that means that we have two solutions. So we have two solutions for part D. So how many zeros? We have 2 zeros. And next, are the zeros rational or irrational? I'm going to look at the discriminant again. If the discriminant is a perfect square, such as 81, since this is a perfect square, that means that that my solutions are going to be rational. So the discriminant tells me quite a bit about what this looks like. And if you're curious about where this discriminant is coming from, the discriminant, if you write the quadratic formula, so the quadratic formula looks like this: x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. If I look at this inside right here, this part inside the radical is called the discriminant. The reason that this tells me so much about this, this is really only going to be, it's going to give us no solutions if this is negative. If this entire thing is negative, then we can't take the square root of a negative number. Therefore, we will have no real solutions. If it's 0, this plus or minus 0 will give us, basically, we don't have an error term here. If we deviate 0 from this part right here is the vertex. If we deviate 0 from the vertex, then we are basically staying on the vertex and we have a single solution. That's what a parabola that just barely touches the x-axis will look like. And then if we have a positive number, then we will have some kind of error. This plus or minus, we will deviate some from the vertex, and that means that we will hit the axis twice. Now, the reason that it tells us about whether it's rational or irrational is because this is a fraction, and the only way that we can get an ugly fraction, thereby making it irrational, is if this is not a pretty square root. So if this is an irrational number, the entire thing will be irrational. The only time that we will not have an irrational number is if we have a perfect square on the inside. Therefore, if this b squared minus 4ac is a perfect square, that means that this number will be perfect square. When we take the square root of it, we'll get a nice round rational number, which makes the entire thing rational. So that's the reasoning behind why the determinant gives us so much information. And if you play with this a little more, you'll see why those things are, and it'll start to make sense after a while. And then to find the solutions, we use the quadratic formula, which we just wrote down. Let's write this again from scratch. I'm going to write it from my standard form. Y is equal to x squared plus x minus 20. I'm again going to write a, b, and c. A is equal to 1, b is equal to 1, c is equal to negative 20. Don't forget this negative sign here. And then I write my quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Now I get x is equal to negative 1 plus or minus the square root of 1 squared minus 4 times a is 1, c is negative 20, and then that's all over 2 times 1. That gives me x is equal to negative 1 plus or minus the square root of, and again, I come up with 81. I just found the determinant, or excuse me, the discriminant. I know that this comes out to be 81 because of part C, and if I put that all over 2, that will this is a nice form right here, but this is not simplified. Do not think that you can just leave this on a test. X is equal to, it's much simpler than what we started with, but this, anytime we ever have a nice square root on the inside, we always want to bring it out. Plus or minus more square root, 6 square root of 81, which is 9, and then that gives us negative 1 plus or minus 9 over 2. If I split this into two equations, x is equal to negative 1 plus 9 over 2, and this will be an OR situation, and we have that x is equal to negative 1 minus 9 over 2. This is just an order of operations thing. X is equal to x is equal to positive 4. If you plug this in on a calculator, don't forget to put parentheses around this. They're implied parentheses around the top. If I neglect to put them in when I'm putting them into a calculator, it's going to give me the wrong thing. And my other solution is that x is equal to negative 5. And I am completely happy with this. You could put it in set builder notation, or you could list them out just as a set for negative 5. Oops, curly bracket. So again, if you want to see what the solution is, number 1 looks like this.